So it shouldn't be, none of this should be surprising. It's very, very, very similar to like when we did 2 sample z-tests. You're still checking all the conditions for means. You're just doing it for mu instead, right? So if we're doing a statistical estimate, our point estimate now is going to be the difference between our 2 sample means. We have t-star, we have the standard error, that is 2 sample means. Okay, these formulas still on your formula sheet. It's still a t-star. Okay, your calculator will do all of it for you still. Okay, so for t-star, if you have to do it by hand, okay, you use the smaller sample size for your degrees of freedom. However, when you throw it into your calculator follows this kind of fancy formula for it, and just let your calculator do it. So if you're using the calculator shortcut, let your calculator do it, okay? If you're using if you are for some reason having to do t-star by hand, you use the smaller of the 2 sample sizes, okay? All right, I'm gonna let you go ahead and read this real quick before we get going. So far, are we feeling okay in terms of what the question is asking? All right. Is this an experiment or an observational study? Experiment. Okay. What are my treatments?
If it automatically refills the cups, or if he asks.
Auto versus ask, yeah? Now, if any of you guys are servers in restaurants, okay, I made up these numbers. This should not influence your behavior in any sort of way, okay? So if we end up with a significant difference between the two, don't think that that means you should do one action or the other. I made this up, okay? Everybody good? All right. Now, because this is an experiment, how does that influence the conclusions we can make? We have 2 types of things we think about. Who can we conclude about, and what can we conclude? Okay? Can we conclude about everybody? Because this isn't a random sample. Was there randomness involved? What was the randomness? Coin flip. Okay. And within that coin flip, all right, do you have your formula sheet?
Yeah, it's in my binder. I have to get it really quick.
Okay.
I don't want to take it here or out there.
I'm going to have you go to one of the study rooms.
Yeah. Do you want to leave my stuff here?
Please.
Yeah.
All right. So with random assignment, what does random assignment allow us to conclude? Causality. With random assignment of treatments, remember the whole idea is before the treatments, we assume our treatment groups are the same. So if there's a difference between the groups, the treatments is what caused that difference. All right, so far are we good? All right, let's go through our steps. For the choose, we're going to do a 2 sample t interval for, and I'm going to do mu ask minus mu auto. Everybody good?
Thank you.
Mm-hmm. Everybody good? Okay, and then you might say mu ask is true mean tips for asking about refills. Same for auto refill. Cool. Conditions. Random. I'm going to say, I like to be as specific as possible. So I'm going to say treatments assigned by coin flip. Okay. Normal. And ask is 52 and auto is 65. Those are in fact both greater than or equal to 30. Everybody good? Independent. Individual tip amounts are independent. Does this feel okay?
Individual tip.
Amounts.
So why is it that instead of that less than 10%?
We don't have random sampling. If what's going on is random assignment of treatments, the 10% condition, like that 10% is that when I take one person out of a population, technically my population, my next person, the probability that they're A or B has changed, right? But if my population's big enough, that change is so minor it doesn't matter. Okay, so that's only, that 10% condition only applies to sampling. And that's not what we have in this scenario. Everybody good? All right, from here, have we done all of our calculations so far? I could make you do it by hand, but I never make you do it by hand, right? Like start thinking through what this looks like by hand. Okay. Does anybody see anything that might be helpful? If I go to stat or over to tests, you guys look at, I think it's option 0. 2 sample t interval, right? And like before, it's you can either put it in from data or from summary stats. We're going to choose the summary stats. Which one should I plug in for x bar n or 1? We wrote this as ask minus auto, so x bar 1 has to be the ask stuff. Okay, so we got 8.21, 2.34. 52.
do 94% confidence interval?
Yep. All right, now, when it asks you for pooled, the answer is always no. You never pool your samples. You just never, ever will we do it. So don't ever worry about it. What that means is like trying to create that one giant sample that we kind of did with the p-hats. We just don't worry about it with means. Okay? So, after that, we just go down to calculate. Yeah? Now, again, the rule is if you have to tell it to the calculator, you have to write it down. Okay? So,
For the p-hat, we have to order out loud.
I would just leave, it doesn't have to be a whole number. So, I would do 113.84, something like that. Are we feeling okay in terms of like where these numbers are coming from? Okay. All right. So we are 94% confident. The interval from negative 1.997 to negative 0.243 contains the, and this is where the wording for this, we have to be very, very careful about the wording here, okay? We don't want to say the true mean difference because that suggests the mean of differences. And this is not a mean of a bunch of differences. This is the difference of two different means. Contains the difference in true means of tips. Asking minus auto. For refills. Okay. This was never an issue with proportions because you couldn't do that paired t-test for proportions. Okay? So there is a difference, we'll talk about at the end, like how do you determine whether you're doing a two-sample t-test for mu1 minus mu2 or a paired t-test for mu d. Okay? All right. So you guys, if you were a server based off of this interval, assuming this was actual data and not stuff Meister just made up, would you automatically refill, ask to refill, or neither? Automatically refill? Because what do I know about the difference between the two? It's always negative. So if asking minus auto is always negative, that means asking is smaller than auto. Auto refilling would lead to higher tips. That's what this experiment would tell us if, the data were real. But I made it up. So don't actually change your behaviors if you're a server. I don't know for sure if it would work or not. Everybody good? Any questions? All right, that was an interval. Let's do a test. Have you guys ever heard of this, like using magnets to decrease pain? So let's go ahead and look at this. And so what they did is they have 29 patients were given active magnets, 21 inactive magnets, and then all but one patient rated their initial pain as 8 or 9. Okay. So the first thing I might notice about this is no matter what, are you guys with me that we don't have any of the summary stats? That we might need to real quick throw these in our calculator. Okay, so let's go ahead and put the active magnets in L1 and the inactive magnets in L2. All right, is everybody good? Okay, so from here, let's go through and do this. All right. So now if we're doing a 2-sample test, and we know this is a test because of the phrase statistical evidence, yeah? Okay. So what would my null hypothesis be?
Both treatments would help somewhat.
That the mean for the active magnets would equal the mean for the inactive magnets. And to be honest, guys, because the reason I'm starting with active is I put these in L1, it's going to make our life significantly easier when we get going. Okay? And then what would my alternative be if the magnets reduce the pain?
Maybe be lower.
That the mean pain rating for the active magnets would be lower than for the inactive magnets. Is this okay? All right. Now, and then we would define those variables. Mu A is true mean pain rating for active magnets. And I would call this a 2-sample t-test for mu A minus mu I.
So, what is an inactive magnet? Doesn't even say.
So likely what it is it looks like a magnet, but there's no magnetic pull on it.
It's a rock.
So like essentially, yeah, and my guess is they were all cut the same way and stuff like that. But yeah, it's essentially you're wearing a rock. So far, are we okay? All right, so let's check our conditions. This is where you guys might want to punch me. So we have random assignment again in this particular case, yeah? All right. Normal? We need to make a graph. However, no one ever said that the graph that we have to make has to be a dot plot. Okay? Remember what we said of like, okay, so really small samples, we want to see kind of that mound-shaped and symmetric. But like those like close but not close enough samples in size, which I would describe both of these as, we just have to look at some display that shows no major skewness or outliers. Okay? Is everybody with me so far? So, it turns out that also I gave you this raw data, right? So it's already in our calculators. I'm going to remind you guys that your calculator can build a box plot. I'm going to show you how to do it real quick, and so that you can, what we'll do is we'll sketch the box plots instead of sketching the scatter plots, okay? So in order to do this, the first thing you want to do is turn on your stat plot. So second y equals will bring up the stat plot. Now yours will say plot 1 equals, plot 2 equals. Go ahead and hit plot 1 so that you're bringing up something where plot 1 is highlighted and it looks kind of like this. Is everybody with me so far? And if the on is not currently highlighted, please turn on plot 1. So again, second y equals will bring up your choices, right? And then you've got plot 1, plot 2. All right. Then what you're going to want to do is go down and you're going to want to pick the one that does not connect to outliers. It should be the fourth one. And when you go to pick that, it should only ask you for a frequency, and in X list your frequency should be 1, your X list should be L1. Is everybody with me so far? Okay. The next thing I want you to do is bring up plot 2. So I gotta remember, can you do that? So you see on top where it says plot 1 and plot 1 is highlighted? Go up to that and choose plot 2. And then what you want to do is make sure the plot is turned on. Make sure you select box plot. And then for this X list, you want to tell it to do L2. And when you do that, guys, to do that, you can't just do the alpha key. You see where it's above the 2, it has a blue L2? So hit second 2 to put L2 in that spot.
Frequency is still 1.
Frequency is still 1. And then if you hit zoom 9, I'm going to ignore my... and now you can see... What kind of error?
Syntax.
Syntax. Hit y, just plain y equals, and you're trying to graph a line or something, like make sure those are all cleared.
Should we zoom 6? Or,
Zoom 9.
well, I mean, for like the window, or will it already set to that?
If you do zoom 9, it'll fit the window to the graphs.
Okay, there we go.
Is everybody good? And do your graphs look kind of like mine?
How do we get like the numbers on there?
Great question. We should hit trace. And when we hit trace, so right now, this is my lower one, right? If I hit trace, and then I hit move right, it'll tell me, right? If you hit trace and then use right or left, you can see, and you guys probably might have to go up, down to go from graph to graph using the up and down arrow keys, and the right and left will tell you which ones are which. Is everybody good? All right. So if this were the AP exam, you would sketch these graphs. I'm comfortable with us just saying, for time's sake, no major skewness or outliers. Independent?
The responses are independent of each other.
Individual pain ratings are independent. Again, trying to be as specific as possible. Are we good? All right, our next step. We're going to hit stat, arrow over to test. You're going to do 2 sample t-test. Option 4. And again, in this case, what we have is the raw data, right? And our alternative was less than, so like your frequencies will still be 1 and 1. Just an error. We doing all right? Is anybody like looking at these 2 sets of numbers? Do you guys see how much how many 8s and 9s and 10s there are for the active or for the inactive versus active? Okay. All right. So what's our conclusion? Since I'm going to make a little sidebar real quick. You guys, I wrote my answer in scientific notation, which is totally fine, okay? One of the things I want to point out that has caused students some problems in the past, a reminder that your p-value is a probability, okay? If you see this and see this answer for your p-value, and you see 3.05, and you write your p-value as 3.05, you will automatically get an I for the calculations box. Because the minute you say your p-value is larger than 1, you are communicating that you don't actually know that you are calculating a probability. Because can a probability be bigger than 1? And I have seen some rubrics, this is one of the few mistakes, that if you compare 3.05 down here, you get double dinged twice. This is one of the few things I have seen on rubrics where if you reference a p-value that is not a reasonable p-value, then you're still showing that you don't know why we're making the conclusion that we make. Is everybody with me? So you want to be really, really careful when your p-value is in scientific notation. However, you may absolutely leave that answer in that scientific notation. So this is an example where we can conclude cause and effect. We can't conclude it about everybody because they only had people with chronic pain. So we can only conclude this about people with chronic pain. Okay. All right. The last thing we need to talk about is we've had tests where our null hypothesis might be mu d equals 0 and mu d is greater than 0. And then we've also had tests where our null hypothesis, just now we learned, right, where it could be mu a is equal to mu d or mu b, and mu a is greater than mu b. So how do you decide? This is a two-sample t-test for mu a minus mu b. This is a paired t-test, and they are not the same thing. Is everybody with me? So we can only use that paired t-test if we have paired data. And so as I give you a set of numbers, you need to be able to decide, is it paired data or not? Okay? And in fact, on your homework that you turned in on Friday that I can pass back if I don't run out of time here, okay? Because it's all graded and stuff. Like on that one, you did the paired because you didn't know how to do the two sample yet, and you should have done the paired. So the question is, how do I decide if data is paired or not? And the easiest way to describe that is if I look at, say, go back up to this, is there any reason I can directly compare, this 0 to this 4? These are two completely different individuals. There's nothing that pairs them together. Okay? So this sounds silly, but in order to do a paired thing, your data needs to have something that pairs like treatment A and treatment B together to the same, either to the same person or something. Like in a twin study, twin A and twin B are the same twins, yeah? Technically different people. Trust me, Katie would be very upset if I didn't point out that we are two individuals. She gets really upset about that kind of stuff. I couldn't care less. Okay, so looking at these couple examples, I want to kind of talk through, would this be paired versus two sample? Okay, so to test the characteristics of two tire brands A and B, one brand is mounted on one side of a car while tire A is on one side of the car, tire B is on the other side of the car. And then you're flipping a coin to decide, is tire A on the left side versus the right side? Is there something that directly pairs A and B at that particular case?
It's on the same car.
They're on the same car. Is everybody with me? Okay, so if that is the case, this would be a paired T procedure. Whether it be an interval or a test depends on what you're asked to do with it. Okay? All right. Can listen to music while working. 20 factory participants agreed to take part in a study. 10 workers get music, the other 10 do not. This would be two sample. Now, what if I took this study and I said, all right, then 2 weeks later we're going to do this again, but the people who listen to music the first time are not going to listen to music. And you guys with me? And so now for each of those 20 workers you have listened to and not listened to, that would change that into a paired T procedure. Okay, so that ends up being kind of a big idea, is understanding those things, okay? All right, I'm done.